Right.
Hi, welcome to BurgerBot. Finally, the Yumi closes the clamshell while it takes off the ring.
Of course, we don't want the ring with our burger.
Closes the clamshell. And I just love this part.
They work together, see? Two arms are coordinated.
And then grabs the French fry and places it on the tray.
And the last thing you'd expect is that you come into one of these little cafes, and in here are industrial robots.
Yes.
To see robots like this, you've got to go to a factory. And here it is in some sleepy downtown. Okay. So, hi Liz.
Hi.
Thanks for inviting me to lunch.
Of course. I can't wait for you to take your first bite.
Okay, this is going to be lots of fun here. And now this is in a sleepy little town called Los Gatos, California. And when you're walking down the street, the last thing you expect when you walk into a cafe like this is that there's going to be an industrial robot at the end. Actually, two. A Delta bot and then
And a Yumi.
Dorm Yumi bot.
Correct.
From a traditional industrial robots company like ABB.
That's correct.
Normally, you have to go to a manufacturer somewhere, off-site, long field trip and everything else. Here, the public can just come in and begin to see.
That's correct.
So, tell me about it.
You know, I've been in the fast food industry for 23 years. I've managed a chain of restaurants. And I think through the process of managing restaurants, I just realized that there's two things that you just don't know. You really never know the cost of goods. You know, it's all about consistency, transparency, and efficiency in the world of fast food. And I just felt like there was no tool for that, right? That can help make our businesses better. And so I decided I was going to create a robot. 2018, everyone thought I was nuts. Everyone was just like, you're going to do a what? That's just too much money. Like the world wasn't ready for it. And I said, you know, I think this is what I'm going to do. So I created this. And I think along the way, everyone's just like, no, you're not. Like, no one believed in the concept. And so then I decided to actually open up these restaurants, having the first dual concept restaurant in the Bay Area. So Breaking Dawn Brunch in the morning. There's a golden pig. The golden pig is my daughter. She's born a year of the golden pig. Everything on that menu is her favorite. At night, it becomes firstborn. Everything for my firstborn son. Everything on that menu is his favorites. But more importantly, there's burgers on the menu because I wanted to prove concept, and I wanted to prove concept myself. I think the last thing I wanted to do was, you know, take investors' money or take people's money and never actually fully have a prototype that's actually customer facing that can prove itself. So here it is. I'm very proud of the machine. Beyond the hardware that you see here, that's industrial grade, and all the different types of engineering that we put in here. Behind the system is a software, and this software helps an operator know exactly how much onions, lettuce, tomatoes, pickles was used in a day. Tells you exactly how much to order because you know how much was used, how many burgers ran through your system in a day. And so I think the goal here for BurgerBots, you know, and for me specifically, you know, just because I've invested 2 decades of work in here, is that to give people a tool that can essentially help them actually understand what they're doing without killing themselves.
Right.
You know?
Yeah. Now, so your background is hospitality.
Exactly.
Yeah.
I am not an engineer.
Exactly. I know a lot of small manufacturers that keep talking about the need to automate, and they're afraid to take that giant step. Yet here you are. You went ahead and you pulled it off.
Yeah.
Which I think is rather amazing. The other thing is that what you're describing, anyone who's an industrial engineer would say, oh, it sounds like you've got an MES system here. You basically are able to control your consumables. Because anyone who's doing manufacturing, that's what you want to know, how much scrap or waste that you have, how much is in production right now, to really be able to get what they like to say, the KPIs, get an idea whether you're able to sort of hit your targets. So this gives you better control overall, consistency,
transparency,
and again,
efficiency.
Transparency, efficiency. And the other thing is it's like, it's this incredible attraction. You know?
The thing is, Scott, I mean, when I talk to engineers, engineers are like, oh, well, what parts did you use? What cameras? What robots? And I think for me, as someone who built this, not being an engineer, the perspective for me was, what kind of value does it bring to an operator? You know, at the same time, as a customer, if I'm going to come in and I'm going to see robots move, that's only cool for some time, right? But at the same time, the movement, at some point, the movement's the same. I think as for a customer, what's the most important thing is my food good? Is there still service involved? Is the food still fresh? And so you're going to have to tell us what you think about that.
Okay. Yeah. As you can see, I already took my first bite here. I could not wait, and it is great. It's
Oh, here's your ketchup and your truffle.
There's even my ketchup, which I think we already had it.
Oh yeah, we put
dispense on there.
Yeah.
So it's a little bit extra, but no, this is absolutely one of the best burgers I've had in quite a while. No doubt about it.
Awesome. Thank you so much. Yeah, I in the quest of making an awesome burger, I think if you know, it's not even really that hard to make a great burger. Really, it's like, do you use a potato bun? Yes, you use a potato bun. So there's a potato bun on there. Are the vegetables fresh? You know, and one of the things about this machine that I love is that the vegetables are cut right before you. So if you didn't want onions, like for me, if I don't want onions in something, and I'm just I get my food and there's an onion, I'm like, ugh. So here you get to see if it was actually placed or not, right? And then good quality meat.
Yes, and again, like you say, the transparency in the preparation, you're really able to see a lot of what's going on throughout the system. And again, it's, if anyone comes in here, they can quickly study it, understand what's going on.
Yeah.
It's not as complicated as people imagine, because right now, engineers will overcomplicate it sometimes. They overthink the process. And what you're doing is you're taking what are pretty much standard components that are used in industry and just reconfiguring them for your task and making sure it gets done at the end of the day. There's a rule I like to use in engineering. It's called Pareto's Law. It's the 80-20 rule. People interpret it many ways. My father was an industrial engineer, and he explained it. He said, you know, the first 80% of a problem only takes 20% of the effort. The last 20% takes 80%. So what you want to do is like just tackle it first 80% and you'll start getting results. And if you want, you can start attacking the last part there. But that bot is able to take care of everything without a vision system. It doesn't have to overcomplicate it because you've been able to control every single step. That tray makes sure it's exactly where it's supposed to be every single time. And actually, you want things like that. You don't want a lot of variation in your process where a robot has to constantly compensate because it's not where it's supposed to be. If you lock it down, quality gets better and better. They figured out in automotive manufacturing years and years ago.
Yeah.
Brought the robots in because they weren't actually locking things down right. They realized that the faults was upstream.
Oh no!
It's like it was all these other processes. You get your ducks in a row, and then your quality starts to get better. So yeah, this is one way to begin.
Oh well, when I was actually sketching this robot out, so the first thing, you know, I found out was you can't just buy a robot. You actually had to build the brain for the robot.
Yes.
So, you know, I was talking to different engineers and they're like, Liz, you know, these things don't come just to do whatever you think it's going to do. We actually have to program it for you. You have to build a brain. So as I was drawing out the design, obviously this design, I used to make Vietnamese sandwiches. So everything that you see here, it's based on what I used to do for a long time. Then I started researching robots. And what I did was, when I was looking for robots, I wanted to buy a robot that did what it was made to do, right? So for example, the Delta, it's made to place and pick. Manufacturers use it to place and pick. So this is exactly what it does, right? The Yumi, everything that's doing, it's what it's everything it's supposed to do. In terms of, I mean, I just feel like engineers, right? Like when an engineer is building something, they're very focused on what's the end goal here. And so, I mean, thankfully that's what I did, right? I chose the right tools. And I was very familiar with what the health inspectors would want to see.
Yes.
You know, because you're with Soft Robotics. I actually love the tool that Soft Robotics had. That's probably next, but it's because it used pneumatic air, and so we don't have that here right now. But I think that as we move on to the things that we're going to do next, we're definitely going to incorporate that.
Yes. Now the thing about that bot over there, the Delta bot. Do you know what inspired it? You'll love it.
What is it?
Chocolate.
Chocolate?
The idea for that robot was inspired by a couple of professors who did a visit to a chocolate factory in Switzerland back in the 80s.
How cool.
And they were trying to figure out, because
it was meant for food.
It was meant for food from the beginning, because you had little chocolate pralines that were coming down conveyors like this.
Yeah.
And they had to get picked up and put into boxes. And sometimes they had to get picked up and not look in the right location, but in the right orientation in the box, right? You have a little heart-shaped chocolate, you've got to put it in a heart-shaped part of the container.
How cool
and you
is
need to
that?
do it really quickly. And they were trying to figure out how to design a machine for that. And they came up with that idea. And then ABB was like, not the first one to kind of get in the market, but they got, in 1999, they had like a patent that was for the Delta robot in a specific size. And they just, the market went crazy. So that was designed actually for food processing industry.
How? Okay, so I didn't know that.
It's perfect for that. And of course, the other thing you need to make sure that your conveyors, and there are plenty of conveyors in the food industry that are sanitation safe.
That's food grade.
Exactly.
Right.
You don't go out to an automotive manufacturer and say, take that conveyor and put it in there. It has to be food safe.
Yeah.
So yeah, everyone would say this is kind of clean room environment.
Right.
That bot is just a genius for many, many reasons. And that is all the mechanics are very up high.
Right.
All the motors are up there.
Right.
They're nowhere near your food.
Right.
So it's a lot easier to isolate the two.
Yeah. Well, we didn't want grease. We didn't want nuts and bolts. You know, when I was building this, I mean, food, there's two things, right? It's cleanliness and safety.
Yes.
Get those two in line first, right? So that was first and foremost for me. But I mean, I'm so glad you told me that, because when I was picking out these robots, really, it was me walking through Automate shows, right? And just saying, what would I really be interested in here? What would anyone that knows nothing about robots want to look at, right? This was it. Yeah.
Now, so there's a lot of things. The way an engineer looks at it is they're trying to look at, like, what's the payload? So if you're doing pick and place, you're asking the questions like, what's the size of the part? How big is it? And what's the work envelope I have to deal with being able to move that thing around?
Correct.
And so if it's something that's very, very big, you're going to get a really big, brutish bot. But you get something small, like chocolate pralines are very light. So the payload of that doesn't have to be very high, but it has to have a reasonable work envelope. Now, work envelopes can work in a couple of different directions. They can just be very planar, or they can also go up like this.
Correct.
And for the most part, the pick and placing you're doing there is mostly planar. So the Delta will give you a little bit up this way, but it gives you a lot that way, which is what you want. But the main thing is it gives you speed.
Yes.
So it can be really, now you're not using this.
Oh, I am not using it at all. I know.
But when you're trying to take chocolates off there, they're just going like, you can't even see what's going on. They almost probably have to slow them down to make sure the filling doesn't like come out from the acceleration.
Well, yeah. Well, the thing is too, is that this, you know, it's not a collaborative robot, right? But it's in a collaborative environment.
Exactly.
And so, you know, at some point we have to make sure, especially because it's a prototype, we have to make sure that everything that we're doing, it's safe, it's manageable. The last thing you need is someone that doesn't understand robots. Like, oh, hey, look, a tomato stuck. Like, should I go get it? Right. Of course, all of our staff members are trained. Stop, do not touch. But just in case, you know, we have to make sure it's safe for now.
Yeah. Usually you have like a lot of safety protocols. And one of them, of course, is that you make sure you have
everything is glass.
Fencing around there that no one can get in there. So it could be either glass or a screen or something like that. No one could get through there.
So we did that. We actually custom this whole frame. Everything here has this glass here is a bulletproof glass.
Okay.
So everything was.
You really went. Yeah, that's extreme, but sometimes it's sort of necessary.
Yeah.
I was joking a little bit earlier with Raymond that a lot of times when you put safety fencing out like this, it's not so much to protect the humans from the robots, but the robots from the humans, especially here, because everyone's going to be very, very curious.
Yeah.
That bot is a collaborative bot, so
right.
you could get near and it's not going to hurt you. That one, it will really only hurt you if it's moving fast, but at the same time, you want to keep it out there. But you have the other thing is that it has to be sanitary anyways. So you need to keep people.
Yeah, you don't want anyone hovering over your food or your burger.
So like the salad bar, you always have like sneeze guards.
Sneeze guards, correct.
So this here is hermetic. Well, not quite hermetically sealed, but pretty close to that.
Yeah.
Now, the one thing I did notice, this is the question I've had. You're closed on Mondays, right?
Right.
What did the robots do on their day off?
They sleep.
Oh, they sleep. Okay, that's what they do.
You know, his name is Bob, so it's burgers only better.
Okay.
Bots need a break too, right?
Okay, so they get Mondays off.
That's Mondays off.
Good. But that brings up, you know, another thing is that I don't know enough about the food industry, but I know that, you know, health inspections and sanitation is extremely important, and that you usually have all these protocols for the day of how you clean things and what you need to do for that. So you probably do have like hourly schedules, daily schedules, weekly.
Oh, so this machine, first of all, in terms of health, you can't. All of this has to be, in the correct temperature. Um, every shift, we actually clean it. So the morning shift, afterwards, we have to take everything down. We actually sanitize everything.
Okay.
Well, everything is machine washed except for these robots.
Okay.
But if you take a look at this too, the way that this was built, a lot of it does not touch food.
Yes, I noticed. Yeah.
So, like for example, the Yumi doesn't touch food.
Yep.
The trays, a lot of this is already in a box.
Yes.
It's already sanitary. So, in terms of the things that we have to be, careful in terms of cleaning, is really the veggie cutters, and those are maintained very carefully.
Mm-hmm.
We do a very thorough cleaning.
End of arm, as you know, what we can do is
The end effector.
Let's go over. Let's take a look at the end
Sure,
effector, and you
sure.
can talk to me about that.
Sure.
So, we'll go on over here because this is what I suspect is that
The end effector. So when we created this, we worked really closely with NSF, so that NSF can tell us, hey, what are your standards here for sanitation? And so they made sure that everything that we did inside that square was curved, so that's easily washable, and everything just kind of goes down versus gets stuck.
so that is that stainless steel then?
That's all stainless steel as well.
Oh, yeah, okay. So
Right.
basically everything here is stainless steel for being washed on, especially the end of arm tooling.
Correct.
The other thing is that end of arm tooling is very easy to remove.
Correct. It comes off and then we wash it.
And I assume you have multiple copies of that?
Multiple.
Exactly. So you can exchange them during the day if you need to,
Yes.
and then clean them at night.
And just
then go
attach
for
it on.
Exactly. So for the most part, so when you say they take everything down, they take the end of our
So
tooling up.
it's the end effector that they take down. All of this here can just be wiped down with bleach.
Mhm.
That's not a problem. And then all of those veggie cylinders that you see, so this whole thing, the slicing and also the cylinders, they all get taken off to be washed.
Okay. Now, how does that compare to the normal kind of cleaning and maintenance you have to do in the standard kitchen? Because you also have all sorts of equipment that normally has to get cleaned at the end of the day.
It's exactly the same as how we would clean a normal vegetable or meat slicer.
Okay, so we're not saying that this is creating suddenly extra maintenance headaches for you. It's on
No.
par with what was always there. It's
Yeah.
nothing new.
And if something is not, if like I said, if something's not sharp enough and it doesn't cut, we kind of know everything. It's all reported back for us.
Right, exactly. You have data, and data is king when you do a lot of these
Mhm.
things. So again, food grade conveyor systems here. You're very careful to try to reduce the amount of food that might even get on there in the first place. So that was the idea of that ring.
Correct.
Now, was that ring something that you planned ahead of time, or is that something you discovered as you started to build up the process?
Discovered. So we realized that a lot of times when we put the vegetables on, it just didn't lay right on the burger. It just wasn't right in the middle. And you see that a lot of like other burger spots too, where you get the burger and you have to open up your burger and readjust the pickles and the tomatoes. And we're like, hey, if we just put a ring and it just drops in there, it'll just have to stay there, right? So we did that, and it worked.
Yeah.
It was probably the easiest. Thank you for 3D printers, right? But it was the easiest fix.
Right. Now, the other benefit is that sometimes, like if the lettuce misses, because the lettuce is the one that's a little bit harder because it's more chaotic, is that potentially the lettuce will fall off and hit the conveyor.
Yeah.
Right. And now that doesn't happen.
No, because not only is it in the ring, the burger is also in its burger container.
Yeah.
So we have,
So again, you basically, there's double advantage to
Correct.
what you get.
Correct.
It goes on there and it keeps it, and that you still have to clean this down, but the fewer food particles you have in here, the easier it is to clean or
Correct.
sanitation. But
Correct.
again, this thing can all be sprayed down if necessary.
Yes.
And then we come over to what I like about this one here as well. Now, this is what everyone has to understand is that the operator probably has to put the sauces in the correct order. If you mix the order up, then it's not going to know which one's mayo and which one is ketchup
Right.
unless you reprogram something.
Right. It's just all the machine knows is 1, 2, 3, 4.
Right.
And it
Exactly. Now you can overcomplicate it and say, "Oh, vision system out here, AI, and all that's going to figure out exactly what it is." The main thing is if you follow procedures, it's done. You don't have to worry about this extra complexity. It just works.
Correct. And the whole idea for us too was for the setting up of this machine, we didn't want it to be someone that had to be an engineer. We want it to be, like a lot of people are like, are you taking away jobs? Well, no, we're not. We're making jobs better. People who have worked in the food industry for like 20 years and their whole thing was cutting onions, lettuce, and tomatoes. Their whole thing now is setting up the robot in the morning. And they love it. They love it. They're happy about what they're doing. And when they're setting up in the morning, it is not complicated anymore, at all, and anyone can do it.
Yes, yes. And again, like some very simple things here is you have a very wide conveyor belt. You have these two conveyor belts coming around here. They come around the corner. They're going to fishtail and everything and be a little bit out of location. Yet you just have this funnel that helps collar it or corral it, I should say, the correct way so that it will come to this station and everything is working. Now, is this like an off-the-shelf kind of dispenser, or is this something that you had to with your own?
So these two it's our own patent and build. So we made the veggie cutter and the sauce dispenser ourselves.
Oh, and the sauce dispenser yourself. Okay.
Yeah.
So that means you had to come up with the idea of closing it off.
Correct. Well, because sauce strips, right?
Does.
And then there's up to 4 different sauces, and so we're like, okay, every time it's done with the burger, it needs to close. Let it do its last splash, and then we can clean that off at the end.
And everyone knows that if you have somebody dispenses soap in your bathroom,
of course,
you come back in there and there's like all these little drips down there next to the sink, and that prevents it.
Correct.
And of course, the main reason you want to do it is that if that sauce is dripping on the conveyor, it's just going
to keep on going and going.
And an eye for detail. Now, we've got all these little sensors that are here that people may have noticed along the way. That basically is like a garage door sensor that you have to be able to tell whether there's something in the way.
Correct.
So the garage door isn't closed. In this case, it's able to tell the system that, hey,
where the conveyor is.
Tray just arrived, and now the stopper needs to close to hold it in there. And again, you designed your trays in a specific way that the stopper can fit in there and hold it in the exact same location each time. So that's the whole idea, is that you're controlling these positions. Correct. So long as the positions are where they're supposed to be, it will be right. So I didn't realize that. So you came up with this design yourself.
So the veggie and this, it's our own design.
Oh, wow. Wow. Okay. So yeah, now I see why that 2018 you started thinking about it, and it takes a little while to be able to get up to this stage.
For sure.
Absolutely.
It took a lot. Tomatoes took 1.5 years.
Yeah.
Those things have seeds, and then they're soft, and then they're hard, and then they splatter. So
normally what ends up happening in manufacturing is we can control those processes. Yeah. We're not dealing with things that are variable like tomatoes.
Yes.
Parts are coming in almost always the same every time. But you've had to deal with the fact there's been a lot of variability.
We had to deal with a lot of variables.
It's
the size of onions matters. The pickles matter. So, I mean, we had fun. We had a lot of fun doing this.
And you have to deal with 2 standards here. You have to deal with the safety standards of the robots, and then the sanitation standards that come from the food industry.
Correct.
So you need to know both of those standards at the same time.
Yes.
Figure out how to bring them together. Okay, no small task.
It was not small. It was not a small task.
And again, this is interesting where the bot comes in here. Now, I see you have one camera system up there. And I think that's not giving any feedback to the robot, is it?
What that camera system does is that it reads the QR code that's on your tray. And then that QR code works with our software to give us direction on what the customer ordered.
Okay.
So if they wanted onions, extra tomatoes, no pickles, we would understand the direction.
Okay. And then at that point, I make sure everything is done right. But in here, there are no cameras.
There are no cameras.
There's no need for a camera. This is how an industrial robot works. Industrial robot works pretty much in the blind.
Yeah.
It doesn't have to see, so long as you've taught it where everything is, and because we're locking down that tray, always in the right location, the robot is guaranteed that the box is going to be at that location, and it's pretty sure it's in a certain configuration.
Right.
The lid is open, it's been taught, it's trained, and all it has to do is through muscle memory.
Yes.
Do that, and everything will work. Same thing over here is that the fries are always going to be in the same lanes,
correct,
the same location, so it can just go over and pick it up.
Yeah.
Now, what's interesting is that you've got the 2 arms here. Every now and then, they're sort of needed to coordinate together.
Right.
But at the same time, that arm can't reach the fries.
Right.
So we need one for reaching the fries, and then sometimes they have to coordinate together down there. And we'll notice that the end arm tooling is a little bit different, or the grippers. So you had to come up with a different.
Those were our design as well.
Yes.
Both of the designs are completely different, and it was made to just this one was made to just do the fries and the size of that one. The Yumi can't have a lot of load in terms of its weight and what it can do. And so this one was fun as well, because we had to make sure that, our end effectors were really light.
Yes.
Very light.
Now, are they aluminum or are they stainless steel?
They're aluminum.
Okay. So here you're able to get away with aluminum because you're not touching the food.
Correct.
Stainless steel is going to be about 3 times heavier.
Correct.
Yes. And so the Yumi is a very light payload. Exactly. And now what you had to do is you had to come up with a gripper that's kind of multi-purpose, since in one case it has to pick up that ring.
Right.
And that was a different task than what you have to do for being able to cook.
Correct. Correct.
Yeah. Okay. That's really quite interesting. Again, we're going to do probably like another run through of everything that's going on here. Just when it gets busy in here, it's not quite noontime.
Yeah.
Pretty soon everyone's going to get in here.
Yeah. Usually it's the weekends where the kids are just stuck here.
Absolutely. Absolutely. Now this here is like a STEM showcase. Without a doubt.
Yeah.
I'm sure you're getting a lot of Girl Scout and Boy Scout troops coming in here, middle schools, everything else. That, again, they don't have to do an outing to someplace off in the distance.
Right.
They can come right down here and see something. And now we are being exposed to the ideas that bots can be used to do a lot of things. They don't necessarily have to be humanoid. You can still use the traditional manufacturing techniques.
And they can be customer facing.
Yes, and they can be customer facing. Again, if I was to step in there and that bot came over and bumped into you, it's not going to hurt.
No.
The only thing that might hurt me a little bit is the end of arm tooling. You get some sharp edges there, but the bot itself, that's not going to be a danger.
No.
Now, again, it's low payload. And the reason why it's low payload is that if it's too strong, it's going to hurt you.
Correct. Correct.
That's part of the problem. So you've got this thing. It's like we wanted to be able to do useful work, but at the same time, we don't want to hurt any.
And the great thing about, in terms of hurting, the great thing about the Yumi is that they need to be in their environment. Anything that's new, anything that's a little bit different, it stops, it pauses anyways.
Yeah.
Right.
Yeah.
So in terms of safety, I love the safety feature because the moment that anything that's off, it's gonna stop itself.
Now, more than likely, if we look over here, this is always a traditional problem with conveyor systems. A conveyor system is like a railroad. And you need railroad crossings when people want to get on the other side of the railroad. So in this case, you had to build kind of a bridge.
Correct. So we needed to build this so that if we ever needed to get into the controller, we can actually
get in there all the time.
Yeah. And so this right here really is just kind of like a roller coaster, right?
Yep. That's what we call a gravity.
When they're done, and then it just goes down, and then once it's running, it just kind of goes straight to the.
It gets pulled right on in. Now, when that bridge is up, that's going to be an indicator to the system that, whoa, watch out, someone might be coming in.
Something's coming in.
So that will sometimes, depends on how you program it, will tell it stop.
Yeah.
Now, I see the other thing is like you've got the button right down there.
Correct.
To turn everything on and off.
Right. Safety.
Exactly. And of course, we have an e-stop, a big red button over there, which someone can run and then hit. But more than likely, if that thing goes up, that will probably be the first indicator.
Yeah, this thing goes down.
Yep. As soon as that happens, it shuts everything down.
Yeah.
Yeah. So safety and food. I mean, manufacturing safety, food safety are two things you have to be an expert on.
Of course.
This is remarkable. Absolutely remarkable. And again, thinking about this bot, it was inspired by chocolate.
I love that you told me about that.
Yeah.
Because it was made for food. It was meant to be.
It was meant
to be.
Exactly. It is.
It was meant to be.
And again, the genius of this bot is that if you look over at the Yumi, you look out at its arms and everything, the actuators for it are getting very, very close to the end of it. So the motors are there. Whereas for this, there's no motor there. There's no motor there. The motor is in here. And it's all sealed behind there.
Correct.
Very, very far from it. And it's this rather remarkable parallel kinematic mechanism in which these are carbon fiber tubes that are coming down there. It makes it extremely light, extremely stiff. And that's actually a spring in there that pulls those two arms together that goes into that spherical joint. And we can pop that off ourselves.
Right.
So it's incredible. You can actually remove the whole lower element of this if you wanted to very, very quickly.
Correct.
And that's why it's able to move so quickly. And you don't get any, like you say, no grease, nothing down near where the food's going to be. The idea of this, the reason it's so fast is because the motors are up here, the robot's not having to carry its own motors.
Correct.
And right down to the rotation at the very end is done with a really clever telescoping rod that comes right on through here. It has a universal joint down there, and that's it that spins around. So there isn't actually a motor down there at all. Now, you do have a little one for being able to have, I think, That tray has to
The end
open
effector.
and
It
out.
has to go in and out. Correct.
Oh, it does. It does move in and out, or does it move in and out by the robot itself?
No, it actually moves in and out. The veggie slicer, that
okay.
moves in and out.
So it does have to do that. So
Right.
you do have a sliding joint there for being able to do it and bring it in.
The veggie slicer actually does that. So
Okay.
it cuts it and then it moves out itself. Not the Delta.
Not the Delta.
Right.
Okay. Yep. Ah, it moves it. Oh, okay. So it's not actuated.
Mhm.
It's not actuated. The veggie slicer.
Correct.
Okay. And again, the reason you want to do that is that every time you put a motor down there, you're adding payload.
Correct.
And these bots don't like heavy payloads.
They don't like heavy.
Chocolates are not that heavy.
No.
They only become heavy if you eat too many of them.